In this installment, we're going to take a look at a sample calculation for a gun firing a round. And what we see up here is this AR-15, a very famous, what people call an assault rifle. That's used, it's designed for the military and wars and so forth, but civilians can buy it, and it gets used in, it gets reported on and used in a lot of school shootings and other types of terrorist incidents that happen here in the United States. So that's an AR-15, and then over here, the different types of rounds or ammunition that can go into them, and you can see that the bullet, what we have here at the top is the bullet, and these bullets can vary a little bit in terms of the mass and the choices that people use. And there's this difference in the amount of gunpowder or accelerant that's used. It ignites and throws the projectile, the bullet itself, propels it forward. And so you might imagine that this one here, if this one and this one had the same mass, these two had the same mass, it looks like this one has much more accelerant, so this bullet might travel faster than this bullet. So the parameters that I'm giving you in this problem are actually kind of an average for a different range of the guns, which can have slightly different masses, and bullets that can have slightly different masses, which means there can be a plus or minus to the rifle and plus or minus to the bullet. So we are given in this situation, the rifle has a particular mass, so we'll call that the mass of the rifle or mass of the gun. And a round is fired, has a mass, so we've got a mass here, or mass of the bullet. And we'll notice that this is in grams, so we're going to have to convert that to kilograms. And then we have a muzzle velocity of 975 meters per second, so that's going to be the velocity of the bullet. All right, so we're asked first to determine what is the momentum of a bullet that leaves the gun. Well, so for part A, we've got the momentum, P equals mv. We've got the mass of the bullet. Now, the bullet is 3.56394 grams, and we want to convert that to kilograms. So we have kilograms on top, grams on the bottom. And 1 kilogram is 10 to the third grams. So that means we're going to move the decimal place over 3. 1, 2, 3. So this is going to be 0.0035639 kilograms, a very small mass. 0.0035639 kilograms, and it has a velocity of 975 meters per second. Now I want to do a power of 10 estimate here first. So we've got an MV. We've got a mass, which is about 3 times 10 to the minus 3. So we've got 3 times 10 to the minus, it's actually 4 times 10 to the minus 3. 4 times 10 to the minus 3, and then the velocity is 975 to one digit is 10 to the 3, or 1,000. So we can see is that the momentum is going to be about 4 kilogram meters per second is what we would expect the answer to be when we plug it into our calculator. So now we are going to do that. .0.0035639 times 975. And we get 3.4748415. 3.4748315. I believe that's what it was. 3.4748315. Yes, it was. 415. Kilogram meters per second. So now we're going to take a look at the answer. We got an answer of about 4. This is 3.47. So our power of 10 estimate and the calculation agree. And now to express this in correct significant digits, this one has 6 digits, and this has 3. So our final answer can have 3. So we would say the momentum is 3.47 kilogram meters per second. So that is the momentum of the bullet that leaves the gun. Well, what is the change in the momentum? Well, if we look at the bullet, it's inside the gun. Before it fired, it had 0 momentum. Its initial momentum was 0. So, and if it ended up with 3.47, then the change in momentum is equal to the final momentum. And we could do this in a formula. Delta P equals P minus P0. And we have 3.47 minus 0. So 3.47. And so we could look at this in terms of the formula, P minus P0, and if the starting momentum is 0, then the change in momentum equals the momentum. That's the algebra that would express that same idea. Now, what about the change in momentum of the gun? Well, what we knew is that P0 equals P. And P0 equals the momentum after, which is the momentum of the gun plus the momentum of the bullet. And the initial momentum was 0. So if we subtract the momentum of the bullet from both sides, we get the momentum of the bullet is equal and opposite to the momentum of the gun. So if the momentum of the bullet is 3.47 plus 3.47, the momentum of the gun is going to be minus 3.47. So what is the change in momentum of the gun? Well, the change in momentum of the gun is equal to minus 3.47 kilogram meters per second. I should have put my units here as well. And so then lastly, we have part D. What is the recoil velocity? Well, the momentum equals mv, and that final momentum was minus 3.47. The mass of the gun, we are told, is 1.36. V. So V equals negative 3.47 over 1.36. If we go to our calculator, we already have that answer there. We're going to say, we're going to multiply that by -1, so now we have a negative, and we'll divide that by 1.36. So we get minus 2.5503. meters per second. So it makes sense that the cannon, the bullet, which is traveling at 975 meters per second, the gun is much more massive. It has a velocity of minus 2.55 meters per second. Now, the significant digits for this calculation, we could report 3 digits here, and this had 3 digits, so our final answer would have 3 digits. So we express that final answer as minus 2.55 meters per second is the velocity of the gun.